So I'll run through these quick. Imaginary number I is defined as square root of -1. That's perfect. Keep that one memorized. I equals the square root of -1. Which one is equivalent to these? So the first thing you always do when you see the square root, remember this thing's got a little 2 there, and it's got to be the square root. This only works with those and fours and sixes. Um, got to be an even number, in other words. You ignore this if it's a 3 right there instead of a 2. But this is, and there's nothing there, it's a 2. And so immediately what you want to do is, you don't have to write this, but this is what's going on. This is how we simplify radicals. We can write them as a factored pair, and then you can separate the factor pair like this. And then this immediately becomes just an I, because the square root of -1 that we just defined is equal to I. And so then it's just a case of trying to simplify the 128. Now, in practice, you don't show all those steps because after a while we get tired of showing all those steps and we say, hey, I've got the square root of a -128. I immediately go, well, that's going to factor out a -1 that I have to square root. And so I immediately just poke out that I like that. And then it's a case of trying to figure out how 128 factors so you can square root it. And the only rule that you have here is as you start to break this thing up, like 1 times 128 doesn't do you any good. 128, I don't know why I put that. You wouldn't factor it that way because square rooting the 1 doesn't help you, right? You want to factor this thing just so you can find hopefully perfect squares. So like I always check for, if I think about my perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You get the idea. But these are the numbers that I want to try and find inside of here. And so I go, hey, if I divide by 2, I get 64. Is 64 a perfect square? Well, apparently I stopped my list too short because 8 squared is 64. What that means is I can square root that. Just like I separated the -1 out, I can take this 128, write it this way. Remember, I got that I sitting out there still. And then again, I just separate and say, well, that's the same thing as the square root of a 2 times the square root of a 64. But there's the perfect square that I can square root. That thing's just equal to an 8, right? That's not like square root of 8 now. It's just by definition, the square root of 64 is simply an 8. So we replace the root 64 with an 8. And the 8, right, it's a root 2 times an 8, and we usually don't want to put the times behind it. So we put the times in front of it. So the root 2 is still getting multiplied by the 8. But the root 2 is also getting multiplied by the I. So it really just comes out to an 8 times an I times a root 2. And we just write it in that order because it's nicer to trap the I in between the radical and the number that's out front. Okay, so we're clearly getting that answer right there, but that's the reasoning why. And so let me illustrate this again. These are both square roots and they have the negative sign. So I poke out their eyes. 16, poke out the eye. Right now it's a positive 16 and a positive 9. And these, by definition, square root of 9 is just a 3. So that's 3 times I, or I times 3. And this is square root of 16 is a 4. So it's 4 times I, which we write this way. And those can just be added. I've got a total of 7 I's. Oop, oop. Which of the following powers of I is not equal to 1? Oh my gosh. All right, so here's the little pattern. And you just build this. You go, all right, I is equal to square root -1. I squared is equal to just -1. The way that comes about is like if I square the I, which is gives me this line here, I would square this side. And when you square something that's square rooted, you get what's ever under the radical. So we get -1 there. So that's a quick explanation of why you get that. But you could also just memorize it, right? I squared is -1. That's about all you have to memorize because your next one is I cubed. But I cubed, if we think about it, is really an I times another I squared. That adds up to a total of 3 I's being multiplied together. I squared, we just saw, is -1. So this now is I times a -1 or negative I. So I cubed is negative I. Ooh, boy. But again, I just derived it, right? So it's negative I. And then I to the fourth. That's like an I squared times an I squared. And I squared is equal to a negative 1. So it's negative 1 times negative 1, which is a positive 1. Alrighty, so how does that help us answer the question? Well, if I can write it as an I to the fourth power, all of these problems, then it would be equal to a 1. Okay. So for example, this I to the 16th, I could write as I to the fourth power, which is a 1 raised to the fourth power, because the power to power rule says you multiply these. So this is I to the 16th, but I to the fourth power is 1. So it's 1 to the fourth, which is just 1. So this one is certainly equal to a 1. All right, let's see if we can do the same thing here. So I write this as I to the fourth, because that's a 1. And 4 goes into 32 8 times, so I could write it as I to the fourth, a 1 raised to the eighth power. So it'd be like 1 raised to the eighth now, so that's equal to 1. So E works. I'm going to jump down to number 4 here, so I don't ruin the surprise there. So I'd write this one. Can I write this as a 1, I to the fourth, raised to the, let's see, 12, because 4 times 12 is 48. So this is 1 to the 12th, so it's equal to a 1. And then that would clearly mean it's the last one that doesn't work. So let's see here. I could write this as I to the fourth raised to the, 4 doesn't go into 26. So I couldn't do that. I could maybe write it as an I squared to the 13th. But I squared is negative 1. So it's negative 1 to the 13th, which comes out to a negative 1 because you got an odd number of negatives. So there's the culprit. He will not give you a 1. Solutions to this guy. Oh boy. So um, let's see. Oh, this won't be bad. That's just a constant term, right? Doesn't have any x's next to it, and so is that. That's a constant term. So that means we can put them together. I just got to get that 7 on the other side by subtracting it. So now I got 0 on the right, 1/3 x squared plus 3. And then I go, oh man, so this is a quadratic equation, and it's missing the middle term. And if I got a quadratic without a middle term, there's a quick way to solve it. So step 1 is get the x squared alone. So I actually did a poor choice on my first step. Now I subtract 3 because I don't want it equal to 0. Instead, I'm going to get the x squared alone. I'm going to take this side times 2 because 2 times a half is 1, x squared. Then I have to take this side times 2. Gives me -6. And now I can just square root both sides. Okay, so on the left side, I square root the x squared and I just get x. And on the right side, when you square root, you always get plus or minus, and it's root -6. Then I use the old poke out the eye trick. Can't square root a negative, so I take the eye out to indicate that. Oh, here, there's your two answers. X is either an I root 6 or a negative I root 6. And none of those are my choices. All those solutions. So where did I make a mistake? Crud, that's not a 1/3 or 1/2. That was a 1/3. Yuck, yuck, yuck. That's all right. Math still flows, and it'll still be the same math, just with a different number. So let's do it the right way now. Okay. So my analysis at the very beginning, I should have said, hey, there's no B term in this. There's only an X in this single spot. I'm just going to get this term, this X squared alone. And then I would have gone -10. Oops, there we are. -10, -10, both sides of my equation. 1/3 x squared equals -3. I'd get rid of the fraction by multiplying both sides times 3. And then I would square root both sides. And instead of having a 6 over there, I got a plus or minus I because I poke out the negative I, -1, make it an I over 9, or root 9. But root 9's a 3, so it's I times 3 or 3 times I. There we go. Now we're going to get one of those things. Solve each of the following incomplete quadratics. Incomplete quadratics. What that means is there's a full quadratic. You have all three terms. You have your quadratic term, something with an x squared, your linear term, something that has an exponent of 1, and your constant right there. And these are incomplete ones, so they must be missing something. Express your answer in simplest radical form. So this one has no x term. This one has no x term. It has an x squared term, has an x squared term, but no x term. And so we're going to solve them just like this guy up here. All right, let's get the x squared alone. So I'll go minus 100, minus 100 to x squared equals, ooh, both negative, so I just add them together and keep the sign. Don't want that 2 next to my x squared. I want that to be just a pure x squared. Divide by 2, that's 81. Because now, see this, now that the x squared is alone, it's easy to square root. And now I have to get the plus or minus here. And I got an I that I'm going to poke out. Gives me the 81, and the square root of 81 is just a 9. 9 times 9 is 81. So the square root of 81 is a single 9. So we poke out the I and the 9, and we get 9 times I. There we go. Plus or minus. Same deal here. If you want to pause it and try it on your own, do that. But just try and get the x squared alone first. So here's the work I do. I go minus 20, minus 20. 2/3 x squared equals, some people have a hard time with this, opposite sign. So just do the big number, subtract the small. 20 minus 2 is 18. Keep the sign on the bigger one. Negative 18. See, now I got to get rid of this fraction. So I do the old reciprocal trick. I multiply the top times the 3 because it'll cancel with the denominator. And I multiply the denominator by a 2 because it'll cancel the numerator. Do the same thing over here. I multiply this side by 3 over 2. Notice how I set that up though. My negative 18's in the numerator. It's like being over a 1. So I go times and I put my 3 halves like this. So I know to multiply the numerators and divide by the denominator. Okay, so here, cancel, 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 cancel. They really just make ones, 2 over 2 and 3 over 3. And then over here, yeah, I could multiply these first right here, but I'm going to do my division first. 2 goes into 18 9 times. That's a negative 9. And so negative 9 times 3, negative 27. Now I just got to square root it, right? Unfortunately, 27 isn't a square rootable number, but we'll just go digging into it and find out what can come out. So first I take out the negative. Then I start to factor my 27, but 27 has a great common factorization, 9 times 3. And that's what I want because 9 I can square root, right? This 3 he's just going to have to stay in there. But when I square root the 9, it's just going to be a 3, right? Just as a 3 right there next to the I. So it's I times 3 or 3I. And then the 3 that stays in is that 3. And there's my answers for x. Plus or minus 3I root 3. Two answers, positive 1 and a negative 3I root 3. All righty, which reset solutions to this guy? Same deal, right? No B term, just constants and the coefficient or the x squared term rather. Okay, so we got opposite sign. So I always just take the big number and subtract the small number, get 25, and keep the sign of the bigger one. So it's negative 25. Gonna get rid of the old fraction there. Just Q off the denominator. Denominator's 2, I multiply by 2. Cancel, cancel. X squared equals negative 50. And I square root both sides. Plus or minus. Okay, got the square root of a negative, so I outside him. Then I got to factor this 50. And so like 50, you could go with 5 times 10, for example, but you can't square root those. So I would use 2 times 25 or 25 times 2. That's still 50, but the 25, I know the square root of. It's a 5. So the 5 comes out, multiplies by the I, and I get 5 times I times a root 2. And there we go, plus or minus 5I root 2. Oh boy, now we're simplifying powers of I. So do you remember this one? That was earlier. I squared. This one is by definition just a negative 1. I cubed. That would be like an I squared times another I, and I squared is negative 1 times an I, so it's just written as negative I, not negative 1 times I to the fourth, you remember that one? If not, we can figure them out. It's an I squared times an I squared, but I squared is negative 1, so negative 1 times negative 1. I think that's an 11. All right, so let's see here. 11. We got to try and break this guy up into things we know, like I squared. So maybe we could do it times I squared. So hey, this is like an I squared to the fifth power, but that only gets me 10. 2 times 5 is 10. So times another I. It's an I to the first, so that would just add, give me I to the 11th. So let's see here. I squared is negative 1. So it's negative 1 to the fifth times an I. Well, a negative to the fifth power will still be a negative 1, right? That's an odd number of negatives multiplied together. Looks like a negative I. Probably not the easiest way to do that one. I could do it. Yeah, I think that's pretty much it. Have to do it that way. Um, 41. This one, 4 goes into, so I guess I could have taken 4 into this guy, but I think it'd be awkward because if I did I to the fourth, be a 2 up there, and that gives me 8. And so I'd still have to take it times another I cubed. But I cubed, I don't even have, oh, there I go. I cubed is negative 1, but then I have to, well, I could take it times a negative 1 at that point. So if I did it this way, I guess, I to the fourth is 1. So this is 1 squared times I cubed is negative 1. I think it was, no, negative I. That's the one, that's why I didn't want to do this because I can't remember I cubed all the time. And so it's 1 times negative I, which is also negative I. So there's an alternate way to do it. This one, the 41, it's divisible by 4 so clearly. So I'd go I to the fourth to the 10th power. That's a 40. And I just need to take it times one more I, so they add up to a 41. I to the fourth is 1, so it's 1 to the 10th power times an I. But 1 to the 10th is just 1 times I then, so it's just I. I know it gets confusing, I's and 1's flying all over the place. Here's an I to the 30th. So I could divide by I could do like I cubed to the 10th, but then I'd have to use this one and say, well, that's negative I raised to the 10th power. And then I got to figure out what that darn thing is. So that's not a very effective way to do it. Okay. I could use an I to the fourth and say, well, 4 goes into 37 times. That's only 28. So I'd need it still times another 2 i's or I squareds. That wouldn't be too bad because I squared is negative 1. And I to the fourth is just 1. So it'd be a 1 times negative 1, which comes out to negative 1. So that's one option for doing it. Maybe I want to do I squared. So I could do I squareds like this. I squared to the 15th power, because that multiplies out to a 30. And I squared is negative 1. And a negative number to an odd power, that gives me an odd number of negatives. So they don't pair up and give me a positive. End up with an extra negative, and we get negative 1 that way. So that would work. Hope that's what my previous answer was for it. So either way, I'm gonna go back to my other one, make sure I get the same thing. What did I just have there? Negative 1. All right. Let's see if I get negative 1 by doing the 2 again. What I just did. Oh, I did 2. I want to do the 4 this time to get negative 1. So I'll redo it with a 4. Uh, I to the fourth raised to the 7th power times an I squared, which is negative 1. And this is just 1 here, so I get negative 1 that way. All righty. The 25th. 4 goes into 25, what, 6 times with the remainder of 1? So that's a good one to use. Goes into it 6 times. That's 24 now. 4 times 6 is 24 times another I. So they add up 25 for an exponent. I to the fourth is 1. 1 to the 6th is 1. 1 times I is I. Get the idea? And let's see here. Again, I don't want to use I cubes because I have to use negative I then. You want to use I to the fourths and I squareds. So this is a great candidate for an I to the fourth because 4 goes into 36 9 times. So it's 1 to the ninth, which is just 1. I think you get the idea. I'll go ahead and finish them out. Stop them and try them on your own at any time. Let's see here. 4 goes into 51. Well, times the remainder of 3. I think I'm going to use I squared. I squared goes into it 25 times. That's 50, so I just need one more I. I squared is negative 1. So I'm taking an odd number of negative ones, and hopefully you understand that. It's like when I have an even number of negative ones, they always give me a positive. So like oops, so like negative 1, if I square it, that gives me an even number. If I take negative 1 to the fourth power, to the sixth power, to the eighth power, they always come out to be positive ones. If you have an odd one like this one, then you get an extra negative 1. That's what your answer is, times an I. There you go. So that's negative I is how we write that. You could write negative 1 I, but that's the same thing as that right there. 45, let's see here. I could divide that by 4. It goes in there 11 times. That gets me up to 44. Then I have to take it times one more I to get to a total of 45 I's multiplied together. I to the fourth is 1. So it's 1 to the 11th times an I, which is 1 times I. And 2 left on this group. Divide by 4, right? 4 goes into it nice and evenly. And that's just 1 to the 20th, just 1. And finally, I to the 70th. I'm going with I squared because I squared goes into it 35 times. 2 to the 30, or 2 times 35 is 70. I squared is negative 1. And I've got an odd number of them. So it comes out to a negative 1. Holy cow, this is kind of a crazy question. I to the 7th plus I to the 8th plus I to the ninth. So one thing I want to make sure of is understand you can't add these together because think about variables. If this is x to the 7th and x to the 8th, they are not like variables, or like terms, we'd say. Right? These act just like that. You can't just add them. They're different numbers. I to the 7th is a different number than I to the 8th. So you can't put like, hey, I've got I to the 15th. That won't work. Because they're just different numbers here. So let's just figure out each one, I guess, individually. I'm trying to think if there's some shortcut you could do with this, but I don't think there is. So let's see here. I'm just going to do exactly what I did up above. All of these problems, same way. I go, I'm going to write it as I squared. That's an I cubed times an I. That's the I to the 7th. So these two multiplied together give me I to the 6th times another I would be I to the 7th. And so I'm going to simplify what I to the 7th is. I squared is negative 1, then it's cubed times the I. Negative 1 cubed is negative 1 times the I. So negative I, that's what I to the 7th is. Now I go to I to the 8th. I'm going to use a 4 for that one because 4 goes into 8 evenly. I to the 4th is 1, and 1 squared is just 1. So now I'm at plus 1. I'll do my I to the 9th. I to the 9th is an I to the 4th squared times an extra I. So I to the 4th is 1. 1 squared is 1. So this is 1 times I. Or just, I'll go ahead and write it there, 1 times I, which is 1 times I, which is I. So now I got plus another I. Ooh, those two I's cancel each other. So I'm going to get rid of those. I'm down to 1 plus whatever I to the 10th is. So I'll pick my last color here if I can find. There we go. We'll do this in blue. I to the 10th. I'm going to do him with an I squared because the 2 goes into him evenly. I squared is negative 1 to the 5th power. Negative 1 to the 5th, that's an odd exponent, so it comes out to negative 1. So now I've got a minus 1 attached down here, and that's going to cancel with this positive 1. All these terms add up to a 0. Answer 4. By the way, if he lets you use a calculator for this thing, we can see that the video clear. I'm going to hit my mode, and I've got to make sure down here where it says real that I'm in that A plus BI. So I'm going to toggle it a few times there so you can see it. A plus BI. Now I'm in complex mode, and I just go quit, and I could go I. You got this button here. It's right above the decimal point. So I go blue, raise to the seventh, arrow over, plus I blue decimal point, raise to the, I'm using the caret button, eighth power, arrow over, plus second decimal point, raised to the ninth power, arrow to the right, plus I second decimal point, raised to the 10th. So there it's all entered. Now you can just hit enter. And it did all the math for me. So your calculator will do it as long as you are in the correct mode. Alrighty. Well, I've got another one of these. I just wanted to do it with my calculator, to be honest. Um, but I'll do them real quick here. So see here, I'll write them out 5 times. I'm doing the 18th one. So 4 goes into 18. I'm going to use I squared because I squared goes into it evenly 9 times. I squared is -1 to the ninth. That's an odd power, so it comes out to -1. So it's 5 times -1 or -5. That's my first term. Next term would be plus a 7 I to the 25th. Not divisible by 2 or 4, but if I do it with 2, I'll do it with 4 actually. I'll go times an I to the 4th to the 6th power, so that gets me 24 times another I. But I to the 4th is 1, so that's just 1 times I. So it's 7 times 1 times I, or 7 I's. Alrighty, next one. 2I to the 28th. So it's 2 times 4 goes into 28 7 times. So 2 to the 4th is a 1 times, or 1 raised to the 7th power is just 1. So it's 2 times 1 there, or just 2. So now I got a plus 2 on this. And the very last one, already used that color. Let's see, green. There we go. 6 times, let's see, I to the, I'm going to use I squared because that just gives me a remainder of 1 then. So I'll make this 21 because 2 times 21 is 42. And then times another I is 43. This one's a little tricky. So I squared is -1, still raised to the 21st. But negative raised to the -21st power like that is just going to come out to a -1. And so 6 times -1 is -6. Times that I would be -6I. So then I got -6I on this thing. So let's add up the like terms. The real stuff adds up to a -3, but the imaginary part, 7 minus 6, adds up to a 1. So I'm looking for a -3 plus I. That was a lot of work. Calculator, by the way, you could just type that in like I showed you. It did spit out that answer just perfect. No problem. And then last one, these are just a multiplication problem, right? So we go 6 times 4, 24. Ooh, almost tipped over my iPad. Then I go 6 times -3I, and I get -18 times an I. And then I go 2I times 4, so I go the 2 times 4 is an 8, and it's also times an I. And then the last distribution is 2I times the -3I. This is one you got to be careful. I'm going to write it out so you can see it. 2I times a -3I. So the 2 times the -3 gives you a -6. And the I times I part, though, gives you an I squared. And remember, we've been using I squared. Where did we last use I squared at? Right there. I squared is equal to a -1. Right here, I squared is -1. So this is really -6 times -1. And so this last term, this happens every single time. -6 times -1 becomes just a +6 with no i's in it anymore. The imaginary number has caused itself to disappear when you do I squared like that. Alrighty, so now here's all the terms. If you can see them all, I got to grab another pen here. I had a 24, and now I've got this 6, and those are like terms, and it's a positive 6. Then I had this negative 18i, it's this guy, and I have this positive 8i, and those are like terms. So those get added together, giving me 30 for real stuff, and negative 18 plus 8. So that's opposite signs. So when I add those, I always take the big one and subtract the small one, giving me 10, but I keep the sign of the bigger one. So negative 10, and that counts as 30 minus 10 eyes. And I think that's all of them. All right. It's more help than I probably should give you on that thing, but uh, stop the video once in a while, and hopefully you did.